All right, so sixth attempt, my fifth attempt, the one that I updated or uploaded didn't have any sound. So I wonder if that's because I put my computer in airplane mode. It seemed a bit weird for that to be the issue. But anyway, let's go through this quickly. The last video was 27 minutes. That was crazy. So maybe it's a bit of a blessing for you guys for this one to be a bit shorter. All right, so in this video, I'm going to go through each question, and each question on this quiz is a probability question. They either relate to basic probability or binomial distribution. Okay, so nothing that you haven't covered yet. I'm going to highlight certain words you need to look out for because a lot of people struggle with probability because of the wording, and they're not always explicit in saying, okay, use this to solve this. So you can see in this question here, they've given you information, and from it, we're going to be using the binomial distribution, but at nowhere in this question does it say using the binomial distribution. Okay, so you got to think, well, what words do I need to look out for? All right, so an archer can successfully hit a target with a probability of 0.9. Okay, so that's important. Also, highlighting the important parts of a question just means you can kind of pick them out of all the words. So the archer attempts to hit the target 80 times, so that's important. That's our number of trials. The outcome of each attempt is independent of any other attempt. So when you see the word independent, it does tell us that we're likely to use the binomial distribution. Okay, so we use the binomial distribution when the probability of success is the same each time. And the definition of independent events is that the probability of success is the same each time. All right, another word we need to look out for is given that. So when you see the phrase given that, it does mean conditional probability. Okay, so then we use the conditional probability formula. The conditional probability formula, I think, is on your formula sheet. Okay, but it should also be in your bound reference. You do get a formula sheet with exam 1 as well. So I'm not going to spend now trying to find it, but I'm pretty sure it's on your formula sheet. Okay, so given that the archer successfully hits the target at least 70 times, the probability that the archer successfully hits the target exactly 74 times, correct to 4 decimal places, is. Now, this last part is a little bit deceptive because the way we read it, and also it kind of is different to the questions in your textbook, because we are used to, in the textbook, being asked, okay, what's the probability that they hit the target exactly 74 times, given that they hit the target at least 70 times? But here, in this question, they've got the condition first. Okay, so conditional, oh gosh, what happened there? Sorry. Me being a perfectionist, I don't like that on there. The conditional probability formula is the probability of A given B, is equal to the probability of A and B over the probability of B. Okay, so whatever the second one is, it goes there, or whatever your condition is, goes on the bottom. So for this question here, all right, I'm just going to erase these. We've got, we want to know the probability that X is equal to 74. Given that the archer has successfully hit the target at least 70 times, so X is greater than or equal to 70. Okay, so X equals 74, given that X is equal to or greater than 70. So with our formula, let me just erase what I had here so we can put in what we need to put in. So that order is extremely important, okay? So see how it's written? Given that they successfully hit the target at least 70 times, I would assume students who got this wrong put that first because that's how they're reading it. That's the order they're reading it in. But we want, given that the archer successfully hits the target at least 70 times. So we have the given that symbol, the straight line, x is greater than or equal to 70. That's our condition. All right, so conditional probability, we want a probability that x is equal to 74 and x is greater than or equal to 70 over the probability that x is greater than or equal to 70. So when you think about this intersection, x equals 74, okay, it can't equal anything else. So does it also fit the other condition? So x is greater than 70? Yes. So all we can have on top is x is equal to 74. We can't have any other numbers. We can't have, say, 75 because 75 is not 74. X has to equal 74. Can't be anything else. Over the probability that x is greater than or equal to 70. So in a second, we'll do that on the calculator. There is another thing I want to just speak to you about. This inequality, so at least, means that we are including 70. It's at least 70. So it has to be greater than or equal to. If we use the phrase more than, it has to be greater than. Okay, so at least, so you got to get used to these words, and if you think that you're not going to remember these inequalities, just write them down somewhere, maybe in front of your book or the back of your book or somewhere. So at least is including the number. So we include 70 here. If we have more than, it's not including 70. Okay. All right, so let's go and do this on the calculator. Sorry, I just had it. Lots of what I was actually doing. All right, so we're going to do binomial distribution for x equals 74. So just do that on the calculator. So it's PDF. Now, if you choose the wrong one, you'll soon know because it's asking you for things and you don't have them or you've got too much, whatever. All right, so 74 is the value of x. The number of trials is 80. Okay, so he's attempting to hit the target 80 times and the probability is 0.9. So he's a pretty good archer. All right, so there's your number. I'm not going to write that down because that is going to waste time. So the next one is CDF. So we're looking now at a range. So the lower bound is 70 and then the upper bound is 80 because that's our maximum. The number of trials is 80 and probability of success is 0.9. Just before we get to the answer, when you've got an inequality, it might be a good idea to write the lower, just consider before you put it into your calculator what the lower and the upper limit is. Because often with the calculator, we look for numbers in our work and might not be thinking. So when we get to question 5, I made that mistake when I did it in the previous video with no sound. But lower limit for this one is 70. If it had to be more than 70, it would be 71. Okay, but we're including 70 here and the upper limit is 80. I was just thinking I should pause the video and just see it's actually the volume's actually working. The sound is actually recording. Okay, so my numerator and then my denominator. All right, it's in decimal, good. And I don't need to write that answer because it's multiple choice. All right, so there it is, option C. All right. All right, I did just pause to check the audio and all is well. Okay, so let's move on to question 2. All right, a box contains 5 red marbles, so that's important. So 5 red marbles, 3 yellow marbles. 2 marbles are drawn, so that's important, at random from the box without replacement. So that's extremely important as well. With or without replacement tells us whether the events are independent or not. So if you have without replacement, Okay, so you're taking balls out. So each time the probability does change, they're not independent events. Okay, so we're not going to be using the binomial distribution for this one. It's actually quite easy to do because we're only choosing 2 balls. Just draw a tree diagram. You've been doing tree diagrams probably since year 9, probably earlier. Okay, so we can have a red or a yellow, red or yellow. So that's my first ball and that's my second ball. The probabilities, now you don't even have to fill in the whole tree diagram, doesn't take long though. So 5/8 for a red, 3/8 for a yellow. And then because we've selected 1 red and we've taken it out, there's now only 4 red left and there's only 7 balls left. And then still 3 yellow. If you ever get unsure, remember that your branches should add up to 1. All right, so if I take a yellow ball out, I still have all my reds, so I still have 5 reds out of 7 balls, but my yellows have reduced from 3 to 2. Okay, so we want different colors, so I can have either red yellow or yellow red. Okay, so to do your probabilities, just multiplying along the branches. So 5/8 times 3/7. And yellow red is 3/8 times 5/7. Now these two are exactly the same. All right, if we were to switch the numerators, they would be the same. So you can just say, all right, that's the same as 2 times 5/8 times 3/7. Okay, and that wouldn't be too hard to do by hand. You could also just do it on your calculator for a multiple choice question, or you could just add these probabilities together, which you would do if they weren't the same, but in this case they are. I already know what the answer is. It is option C, but again, just do that in your calculator. All right, question number 3. So if X is a random variable such that the probability X is greater than 5 is equal to A and X is greater than 8 is equal to B, then the probability of X is less than 5 given that X is less than 8 is. So this sort of question, it hasn't been designed. I would like to think that questions aren't designed to trick you, but this question highlights the importance of reading a question properly. Okay, you're going to for some of you, you're going to come across questions in your exam that you're going to be like, I don't even know where to begin. This is not one of those questions. This question you can do. So you would, hopefully, those questions that you look at and you're like, oh gosh, how do you even do this question? You just put a little asterisk next to it, move on, okay? Focus on those that you can do. Give yourself time to understand or to notice that these inequalities change, okay? So if you go ahead and do the wrong conditional probability, you're going to get the wrong answer, obviously. Okay, so if we've got the probability that X is greater than 5 is equal to A, that means the probability that X is less than 5 is equal to its composite. Sorry, not its composite, its complement, 1 minus A. And the probability of X is great. So, sorry, just got my inequality signs around the wrong way. Is less than 8 is equal to 1 minus B. All right, so they're complementary events. So your conditional probability formula, so we want X is less than 5 given that X is less than 8. So we do their intersection. And sorry, X is less than 8. Okay, so the numbers that they have in common. So if we're less than 5, we're also going to be less than 8. So on the top, we're going to have the probability that X is less than 5. Now, in questions we've been doing, it's always been the first condition has stayed on top. Not always the case, okay? So just make sure you don't make that assumption. All right, probability that X is less than 8. All right, so I did this before. So 1 minus A on the top and 1 minus B on the bottom. And then you go to circle your answer and you're like, oh, it's not there. Oh, then you might have a look through. You'd be like, oh, I'm pretty sure everything's right. And, you know, from this point, we all have different thoughts. So let me go through some thoughts that you might have. Okay, doesn't look like A over B, so I might just get rid of that. Okay, those ones don't cancel out. Okay, if it was times, they would. Okay, but you can't cancel out when you have separate terms. All right, B. Well, I've got A minus B on the top. Yeah, I'm pretty sure that's not it. I'm pretty confident it's going to be 1 minus A, 1 minus B on my numerator and my denominator. Okay, so it could be C. Okay, it's not D. And could be E. All right, so you're choosing between C and E. Now, I would say students would then go, oh, looks kind of like C. Maybe I just got my A and B around the wrong way, and circle C. At this point, and for questions like, not necessarily probability questions like this, but questions where you get an answer and it's not one of the options, you shouldn't just assume that you're wrong. Okay, especially if you're quite confident you've done it correctly. You've got to say, well, how can I change this to fit into one of these? Okay, so you need to transpose your expression. So for this one, 1 minus A over 1 minus B. With fractions, you can, you have equivalent fractions. So what, like 1/2 is equal to 2/4 is equal to 25 over 50. All right, so that means that we can change this to make it an equivalent fraction. So what if I multiplied it by -1 over -1? All right, so whatever you do to the top, you've got to do to the bottom. So I'm multiplying it by -1, -1. So basically anything that is positive now becomes a negative. So this numerator, instead of being 1 minus A, can be -1 plus A. And my denominator can be -1 plus B. Still doesn't look like what we have, but I know I can switch my A and -1 around and my B and my -1 around. So my correct answer is E. Okay, so this question is I think 45% of students got it right. It's not a tricky question until you get to the choosing your answers. Okay, so you need to be able to transpose your answer so it fits the options that are there. Okay, let's move on. So question 4, Harry is a soccer player who practices penalty kicks many times each day. Each time Harry takes a penalty kick, the probability that he scores a goal is 0.7. All right, so let's highlight that. Independent of any other penalty kick. So it's not like he gets better each time. He's the same each time. All right, oops, use yellow. Okay, so it's independent. Okay, this is starting to look like a binomial distribution question. All right. One day, Harry took 20 penalty kicks. I think that's a lot of penalty kicks, isn't it? I don't know. Given that, okay, so we'll highlight that in yellow in a sec. He scored at least 12 goals. The probability that Harry scored exactly 15 goals is closest to. So I'm just going to highlight. Where do you reckon I'm going to highlight? Already did independent. Given that. Given that, when you see the phrase given that, it means conditional probability. All right, so the condition is that he scored at least 12 goals. So given that X is greater than or equal to 12. All right, so if it helps, you can put the condition in first. So the given that symbol, X is greater than or equal to 12. And we want to know that he scored exactly 15 goals. X is equal to 15. All right, so that is the probability that X is equal to 15. So we want this intersection over probability that X is greater than or equal to 12. So we can see the phrase at least used again, so very similar to question 1. So if we've got X equals 15 and X is greater than or equal to 12, so the only numbers they have in common is X equals 15 over probability that X is greater than or equal to 12. So very similar to the first question. Let's just do it quickly. No, that's not what I wanted. Okay, so PDF, all right, X is equal to 15. Number of trials, he had 20 kicks. Probability of success, so 0.7. Okay, there's your number. I don't need to write it down. Let's just move on to the next one. So here we've got a range. So our upper limit is 12. Sorry, our lower limit is 12. Our upper limit is 20. Number of trials is 20. And the probability of success is 0.7. All right, so we just want to do this number, drag it down, divided by this number, enter, and there we go, 0.217. Where's my cursor? All right, let's move on to question 5. So let's get my highlighter. Oops. A soccer player is practicing her goal kicking. She has a probability of 3/5 of scoring a goal with each attempt. She has 15 attempts. The probability that the number of goals she scores is less than 7. Now, this doesn't use the phrase independent anywhere, but it doesn't say that it changes. Okay, so the probability of scoring a goal is 3/5 with each attempt. Okay, so I'm just going to go and presume that it's independent. When you've got attempts, okay, that's another sign, okay, binomial distribution, she's having several goes at it. The probability that the number of goals she scores is less than 7. So this condition is, sorry, I should probably use condition because it's not conditional probability, it's an inequality. So we want X is less than 7, okay? It's not equal to 7, it has to be less than 7. Sometimes if you had the, if you want the, not the opposite, but if you wanted to include 7, it would be at most. All right, and there's probably other phrases that are used. Again, put them into your bound reference. So less than, we just use the less than symbol. At most, will be less than or equal to. Now, when I did this question in the other video with no sound, I got my lower limit and my upper limit, sorry, I got my upper limit wrong. And then I soon realized, I knew what the answer was and I knew I got it wrong. So then I had, but in an exam, you don't know the answers. So this is why, you know, in the previous, one of the previous questions, I said, it might be a good idea just to write lower and upper. Okay, so the lower limit, X has to be less than 7. So she could get 0 goals. The upper limit, it can't be 7. We're looking at discrete values, okay, because she can't kick 6.2 goals. So the upper limit is 6. Okay, so we can't include 7, so 1 less than 7 is 6. So on your calculator, let me just get it up. All right, she's had 15 attempts, so I just covered that. Okay, so we've got CDF. So the lower limit is 0, the upper limit is 6, not 7. If you chose 7, it's actually one of the options. So I probably should look at and see how many students actually made that mistake. Now I forgot how many kicks she had, 15. And the probability of success is 3/5. So you could either write it as 0.6 or 3/5. Doesn't matter. All right, and there's your answer, which is B. Okay, so just taking care with that inequality. All right, that's what stumped me first and probably a lot of other students. So writing lower and upper might help you avoid making that error. All right, guys, bye.